Hey y'all, Dr. Johnson here from Southern Research, or better known as the Dr. LL Cool J. I'm coming to you live from my kitchen. Just like many of you, Dr. Lanier and I are working from home. But just because we're not in the STEM lab doesn't mean we can't do some really cool science. You've probably heard a lot about the coronavirus lately on the news, on TV, from your parents. Well, rest assured that the scientists at Southern Research are working really hard to help us beat COVID-19. But what can you do while you're at home? Well, something that you've heard a lot of lately. Wash your hands, use soap. But why is soap so special? Why is everyone telling you to wash your hands? Well, stay tuned because you're about to find out. Today we're going to be doing some cool experiments to help us understand how soap works and why it's so useful against the coronavirus. But I want you to join in with me at home. So here are some things that you'll need. A clear container, some water from your sink, some dish soap, some cooking oil, and then something to stir with. Before we dive in, we have to ask ourselves, well, what is soap anyway? Well, soap is made by treating oils, typically from fats of plants or animals, with a strong alkaline solution like lye, which is sodium hydroxide. And guess what? Humans have been using soap for well over 5,000 years, so it's nothing new. But why do we use soap? Well, to get stuff clean, of course. But why not just use water? Well, dirt is oil-based. Do you think oil and water will mix? Well, let's find out. So grab your container and fill it with just regular water from your sink. And now we're gonna take our oil and we're gonna add some of our oil to the water. And we're gonna see if they mix. So take a look. You can look here on the screen or look up close in the one that you're doing at home. You notice that the oil is now floating on top of the water. They're not mixing. Well, maybe we need to give it a little stir. So let's grab our stir rod and give it a nice swirl. Try and get it nice and mixed up. What do you notice? Is it mixing? Even after stirring really hard, the oil is staying on top and not mixing with the water, no matter how hard we try. Why do you think that is? So our oil and water didn't mix. Do you know why that is? Well, water is a polar molecule and oil is a non-polar molecule. So what's the difference? Well, polar molecules typically have a charge, whereas non-polar molecules do not. They have a neutral charge. And when you're thinking about whether or not things mix together, remember this rule. Like dissolves like, meaning polar molecules are going to dissolve with other polar molecules, and non-polar molecules will dissolve with other non-polar molecules. But polar and non-polar just won't mix, just like what we saw with our oil and water. They're not gonna mix. So what do polar and non-polar, or water and oil, have to do with the coronavirus anyway? Well, let me tell you. The coronavirus has a bilipid membrane and these spike proteins. The spike proteins help it invade the host cell. The bilipid membrane helps protect the virus and allows it to stick to surfaces like our skin. The bilipid membrane has fatty acid tails, which act and behave just like oil, meaning they don't mix with water. So we can't use just water to wash our hands free of the virus. We've got to use soap. Well, soap is a really special molecule. It's an amphiphile, amphi meaning both, phile meaning loving, because soap loves both polar and non-polar substances. The polar head likes to mix with other polar substances like water, meaning that this part of the structure is hydrophilic, or water-loving. The non-polar tail likes to mix with other non-polar substances. And just like we learned, non-polar and polar substances don't like to mix. So this is often referred to as hydrophobic or water-fearing. So how does soap help us battle against the coronavirus? So when you're standing at the sink, washing your hands together for 20 or more seconds, soap is coming to the rescue. These non-polar tails of the soap molecules are afraid of water. Remember, they're hydrophobic. So they're trying to get away from the water on your hands when you're washing your hands. They're also attracted to the fatty acid tails of the by lipid membrane. Remember, that is nonpolar and so are the fatty acid tails. So through these processes, the soap molecules are gonna wedge themselves into the lipid membrane, prying it open and spilling out all the guts of the virus, effectively breaking it up into teeny tiny pieces, making it no longer able to infect us. And what is happening on an even smaller level is the soap is forming what's called a micelle. So these soap molecules are attaching to all the non-polar pieces of the virus. That also includes all the oil on your hands, all the dirt on your hands, and all the pieces of the virus. But how do you wash your hands clean? You've got all these bubbles all over your hands that are these micelles with the dirt and virus trapped. Well, that's where water comes into play. The polar heads of the soap molecule are attracted to water. So when you rinse your hands clean, it washes away all these micelles, leaving your hands nice and clean and virus-free. But don't take my word for it. Let's try it out. Grab your glass that has your oil and water. So in this, the oil is going to represent that lipid membrane in the virus, right? And remember, if we stir this together, no matter how long we stir, it's not going to mix, right? Just like if you were to wash your hands with water, it's not going to kill that virus or get it off your hands. What do we need to do? Well, let's add some soap. So grab your dish soap. Let's add a couple of drops in there. And let's give it another stir. Let's see if the soap is coming to the rescue. Wow, what do you notice right off the bat? The oil and water look to be mixing. Well, why is that? Well, remember, the soap molecules have both a polar head and a non-polar tail, right? So the polar head is attached to the water and the non-polar tail is attached to the dirt. There are a bunch of these little micelles all inside of this glass jar right now. And so what it's done is it's effectively attached to all of the oil. So when we rinse our hands clean or rinse this jar clean, all the oil is gone, right? You don't believe me? Let me rinse it out real quick. Give it another pour. There is no oil left, just a little bit of soapy bubbles. And that's exactly how hand washing works. Thanks so much for tuning in. I hope you had a lot of fun and learned why it's so important to wash your hands with soap for at least 20 seconds to help us continue to battle against this COVID-19 pandemic. See you next time.